In this video, we're going to talk about substitute levels of detail and the benefits surrounding them. Here I have the substitute level of detail IAM from our working files directory. What a substitute level of detail allows us to do is substitute out all the parts and components that make up a certain subassembly or the entire design and really simplify it down into one single part. And we can do that through a couple different methods. The whole goal about this is to create a very small footprint on file where you're only loading one component at a time that contains a lot of the intelligence that you need to know at a very high level. To create a new substitute level of detail, if I go to my level of detail representations and right-click, there is an option here called New Substitute. That flyout has three options. The first one is the Derive Assembly option. This will start the derive component command, allow you to go through and specify how you would like to derive this into a single IPT file. The next option is called Shrink Wrap, which is very similar to the standard assembly shrink wrap protocols inside of the software. Essentially, what that will allow you to do is very similar items to the derive assembly. However, it takes a lot of the interaction out of it. Shrink wrap gives you an outside skin of your assembly and removes all the internals and fills it with concrete. So you don't get much of the internal data, and sometimes it's hit or miss and can also be very time consuming on very large designs like we see here. In the last option, the Select Part File selection allows you to specify a predefined user part file, and this part file could be something that you already derived manually. This could be you created just a long block with 10 smokestacks coming out of it to represent what you have here in your design, something very, very simple that you modeled on your own. But any selection you make will do the same thing. It will represent the entire assembly as one of these simplified substitute parts. Now, I've already created a file that will represent this particular design. I manually created a derived part of this entire air conditioning unit, and we'll be using that for our substitute. So here I'm going to select the part file option. In my working files directory, I have a file called substitute derived part.ipt. I'll choose that to open it. And we will see a derived part that I have systematically gone through and simplified. I've removed a lot of the internals. I removed parts that I didn't really feel necessary for who I want to consume this to be able to see. You will also notice in the lower right area of the screen, I only have this one component loaded. I don't have all 2,700 components loaded, just this one. And you might be thinking at this point, well, you probably threw away all the bill of material information. How do you access any of the parts list or quantities or weights or anything of that nature? Well, the unique characteristic about a substitute is it maintains your bill of material. It maintains the weight of your original assembly. If I were to right click and go to my iProperties, I would get the proper mass weight off of this. If I were to go up to my Manage tab and look at my bill of material, I need to save this first, as it's prompting me to do so. Let it calculate the mass properties at this level of detail. If you said no, it will calculate them based on the master, which would be more accurate in that case. Go back to bill of material. And here I will see all the information that makes up the bill of material for this design without actually having it loaded. I'll go ahead and close the bill of material dialog here. Over on the left-hand side, you will also notice that a substitute level of detail appears as a different icon in your representations browser. Here it looks like an assembly file that's been kind of all merged together. Looks like a solid L-shaped blue piece there.